Hello everyone. So this is the fourth session of the advances in food analysis, and the topic which will be continuing from the second and third session is the scanning electron microscopy. So how does the signal come from the sample? So when the incoming electron reaches the sample, it gets attacked onto the sample. Then there are backscattered electrons, there are secondary electrons, there are X-rays or cathode luminescence light. So these are the different types of reflections of the electrons which occur as soon as it reaches the sample. So where does these signals come from? So there is the incident electron beam and the secondary electron production. So these are the different phases in which from which the signals can come from, such as backscattered electrons, primary X-ray excitation, and cathode luminescence excitation. The diameter of the interaction volume is larger than the electron spot. Generally from the collision between the incoming electrons and the loosely bounded outer electrons. The loose energy electrons, that is 10 to 15 electron volt. Only secondary electrons generated close to the surface escape, that is topographic information is obtained, and number of secondary electrons is greater than the number of incoming electrons. That is how we differentiate between secondary electron 1 and secondary electron 2. The secondary electron 1 are generated by the incoming electron beam as they enter the surface. The high resolution signal with a beam which is only limited by the electron beam diameter. The secondary electrons that are generated by the backscattered electrons that have returned to the surface after several inelastic scattering events. The secondary electron 2 come from the surface area that are bigger than the spot of the incoming electrons. That is resolution 2 poorer than the secondary electron 1 exclusively. The factors that affect the secondary electron emission are work function of the surface, the beam energy, and beam current. The electron yield goes to maximum at low voltage that decreases with the increased voltage. The factors that affect the secondary electron emission are atomic number. The more secondary electron 2 are created with increasing Z, the Z dependence is more pronounced at lower beam energies. The local curvature of the surface, that is the most important factor. By placing the secondary electron detector inside the lens, the main secondary electron 1 are detected. That is, the resolution of 1 to 2 nanometer is possible. The backscattered electrons, a fraction of the incident electron is retarded by the electromagnetic field of the nucleus, and if the scattering angle is greater than 180 degree, the electrons can escape the surface. That's all for this session. Thank you.